Curious, setting the scene. A mother, 10 days postpartum, lives miles from the nearest specialty care clinic. As the sun sets, she develops a severe headache, tightness in her chest, and sudden confusion. This initiates the critical window in healthcare, the dangerous span of time between when a symptom begins and when a clinician is finally reached to evaluate it. Most digital health tools built to close this gap suffer from three specific design failures. The first is connectivity. Cloud-dependent applications require constant bandwidth. If a household relies on weak rural broadband, the tool fails to load entirely. The second failure is vagueness. Generic symptom checkers are programmed to hedge their bets. When presented with complex data, they return broad, non-committal advice that blurs the line between normal recovery fatigue and a lethal warning sign. The third failure is translation. When an emergency strikes, generic tools do not help a panicked caregiver accurately summarize overlapping high-stress symptoms into the exact terminology required by a 911 dispatcher. The navigation gap isolating these families is a compounding series of digital system design failures. CareBridge is a targeted escalation assistant, engineered specifically to operate when those standard systems fail. This schematic shows how CareBridge severs dependency on the cloud. A lightweight, fast API runs a self-contained data loop locally. Instead of open web searches, grounded retrieval queries a localized, highly curated set of trusted medical notes covering specific crisis events. Operating offline neutralizes the connectivity failure point. A dropped cell signal or a dead router has no impact on the system's ability to assess a symptom. Trading an infinite cloud-based database for a constrained, preloaded knowledge base guarantees that a caregiver receives an immediate evaluation exactly when the internet drops. Medical AI presents a major paradox. Large language models are incredible communicators, but they are highly unpredictable decision-makers, prone to hallucination. CareBridge uses a deterministic safety backbone. Symptoms hit a rigid geometric gate, calculating the medical urgency tier. This layer locks the clinical decision, preventing AI hallucination. Finally, Google's Gemma 4 translates these locked rules into clear, caregiver-friendly language. This solves the vagueness failure point. It provides a readable explanation of why a sudden headache paired with chest pain indicates a severe postpartum complication. This split brain design successfully harnesses the conversational power of a large language model while actively stripping it of the power to make life or death guesses. This is the final output of the CareBridge interface, the clinician handoff card. It displays a clear urgency level, specific warning signs, and immediate next step instructions. This structured card solves the translation failure point. It hands the caregiver an exact, concise script to read directly to a 911 dispatcher or triage nurse. Back home, the mother instantly knows her chest pain is a medical emergency. She has the exact words required to secure immediate transport. This exact engineering framework is designed to handle multiple scenarios, parsing complex warning signs for pediatric fevers and climate-driven respiratory stress from events like wildfire smoke. The future of medical AI is not an unconstrained oracle built to replace doctors. True technological impact in healthcare strengthens isolated families, ensuring the right information safely crosses the navigation gap when doctors are out of reach.